Hi, welcome to IT and Automation, and in this video's tutorial series of Kubernetes. And today we will cover yet another topic, office scaling in Vertical Pod Autoscaler, often referred as VPA. In previous videos, we have covered likes of HPA and other topics around scaling. If you would like to check below description or later on, feel free to browse around our channel. So in today's video, we will cover topics such as what is VPA, why to use VPA, how does VPA work, installation as if you are doing a clean installation of a VPA from scratch, including the operator side of things, and we will look into working example. We will create a Vertical Pod Autoscaler resource. We will trigger some spikes to mimic a real working environment. We will observe the changes, and we shall talk about guardrails and some caveats and gotchas if time allows. So without further ado, let's start from what exactly is VPA. Vertical Pod Autoscaler, often referred as a VPA, is a Kubernetes component that automatically adjusts the resource request and limits, as in CPU and memory, of the running pods in a Kubernetes environment, or I should say Kubernetes cluster. Its goal is to ensure that applications are allocated just the right amount of the resources and preventing both underutilization and overutilization, which by default is tricky in Kubernetes environment. So why would you use VPA? Is let's imagine you have a Kubernetes cluster that runs smoothly under normal condition, but when there is a spike in traffic, or during peak hours or unexpected surge of users, you will often need to manually adjust the resources around request and limits for both memory and CPU side of things. This tuning is not only tedious but also unique to your specific cluster size, workload patterns, and sometimes even depending upon time of the day. So without proper adjustment, you risk over-provisioning, leading to wasted resource and increased cost, or your application is underperforming because it is under-provisioned and causing potential downtime, which may be available sometimes not even available. But if customers are not getting the service out of your application, that should be considered as a down or causing a performance issue. So there is where Vertical Pod Autoscaler becomes essential. So VPA dynamically adjusts the CPU and memory request of your pods based on the real-time usage data, ensuring that each pod gets exactly what is needed and when it is needed. That is not only to help you avoid the limitations of the static resource allocation, but also to provide a smarter approach to resource planning. So with VPA, your application stays responsive and effective without the manual intervention. So it continuously right-sizes the resources and helps you manage those unpredictable traffic patterns, considering the fact that you have enough resources on the node side of things, or if you have a cluster autoscalers and other likes of tools to provision the upper limit of the cluster itself. So in short, VPA automates the fine-tuning of resources requests, allowing your cluster to adapt seamlessly to changing demand. So now, how exactly does VPA work? So VPA monitors resource uses and it analyzes the pattern, adjusts resource request and limit, and then does a pod scheduling and rescheduling. So how this flow works is the process begins with a target deployment, collects the resource uses metrics, where VPA collects the resources using metric like CPU and memory from the running pod, analyzes the metrics, where the metrics are analyzed to determine if the current resource requests are appropriate, compares against the recommended values. The analysis checks if the current requests are under-provisioned or over-provisioned compared to recommended values, and it increases the resource request if the pod is under-provisioned VPA increases it. If it is over-provisioned, VPA decreases the resource request accordingly and applies the updated resource request by updating the pod specification. It also waits for this cooldown period for the next adjustment cycle and repeats the metric collection and keeps on doing this on a background without a user having to have a look at it manually and having to intervene with the spec side of things. This flowchart here accurately reflects on how Vertical Pod Autoscaler manages the resource allocation in Kubernetes. So now time to install VPA. So if you haven't installed the VPA in your Kubernetes cluster, you can install this by, let's begin with the GitHub repository. If you look into Autoscaler project in GitHub for Kubernetes, you will see this Autoscaler repository, which is all things autoscaling, and it also contains the components like VPA or multidimensional pod autoscaler and cluster autoscaler itself. So let's look into Vertical Pod Autoscaler, and this here, if we look into the installation side of things, it talks about compatibility 127 plus requires 121. If we look into, let's do quick export and see kubectl version, and we are looking at 129. We will be good with 121. And the CRD comes with a VPA release 1.1.0. So what you would want to do is you want to install CRD generator and VPA RBAC. These two manifests. When you install these two manifests, it brings up, you will see in the screen here, it will bring up all of the necessary components around RBACs and the other custom resources. So here it has installed autoscaling, custom resource around checkpoints, Vertical Pod Autoscaler. So what does that do is, so here, Vertical Pod Autoscaler, those resources are there. And we also saw cluster roles, vertical VPA most likely, yes, here, system level, those things are there. That got installed. But if you look into pods and you look into vertical, it's not there yet, right? So this too will bring necessary dependencies, but what you also need to do is git clone, get into the Virtual Pod Autoscaler directory, and you would need to run a shell script to do a VPA up.sh. Again, it is to make your life easier. You could do it with a custom installation, with applying those YAMLs as well. So here I have most likely cloned it already. I will do GFA to get the most recent. If I go to Vertical Pod Autoscaler and hack, I do have that script called VPA up.sh. And then now if you look into kubectl get pods grep -i VPA, or here -n kube systems, so there are the VPA related pods as well. So what we did now is we installed VPA component, we installed the VPA resources as well. So now let's look into a working example of VPA. So here I will go a couple of steps back here, and here I have got this Nginx deployment. This particular Nginx deployment here, this is a basic Nginx deployment of the latest Nginx with some CPU request and CPU memory limits, both CPU memory limits and requests. So if I apply this resource So we have created, why don't we do this, K9S, and keep eye on that, pods, and let's go to that. Here we have just created a VPA resource, a resource that we will be scaling up based on those VPA metrics. So we will walk through how to set up VPA next, right? So what we did just now is we have a deployment, and now let's create a VPA Autoscaler resource. So to create a VPA configuration for this Nginx deployment that we are seeing here, you use VPA Nginx. So this is a template of that. So it is a kind of autoscaling vertical pod autoscaler. Name, I'll give it as an Nginx VPA, and the namespace, targeted namespace would be VPA demo here, and we will say what kind of deployment are we targeting, or what is our target reference. Our target reference is apps v1, kind is deployment, and deployment name is that. So if we look into this screen here, that should match our name there. So update policy, update mode auto. In VPA you can have 3 different modes of where VPA will only calculate the recommendations but doesn't apply them. Initial, as in VPA applies recommendations only when the pods are created on the startup, and you can have an auto where VPA continuously adjusts the resources of the running pod based on the recommendation. So for this to get applied, we can run kubectl command again, but let's look into this container name here, right? That's the container name we are targeting. If we go inside that Nginx deployment, that's our container name, and what we are saying is minimum it needs to be that, and maximum it needs to be that, right? But if we look into resources here, we have requests of that and limits of that, which doesn't match, and that is done in a purpose to show you for the sake of this demo. Here, if I apply that with using kubectl apply -f, why don't we also do new terminal here. Let's put a terminal here, set that K9S VPA. There is nothing in there. If I do, okay, let's keep eye on that pod there, or even container. Let's apply that VPA. We should see a VPA demo in here. Okay, here is that VPA resource there. It doesn't have CPU and memory just yet, or the provided, because it's just a new fresh install configuration. It needs to read the details from this above container, and then it will eventually populate the CPU and memory there. So what we can also do in the meantime is, yes, there we go, CPU is 250, memory is that, provided is true. So now if we look into this, limit and request is quite low, but what we demanded is different, right? So we will see in some point in time it will go and adjust those limits, and it also puts the annotation limits. There isn't, but here we have got that, which says, okay, this is my target reference, this is the min and max, and this is our recommendation, which is most likely not different to what we have currently set, and lower bound that, target that, uncapped target, and upper bound. We will talk about this upper bound in some time once we see this being applied. Okay, so we've got a new pod there, new container. Let's see what is the limits there. Okay, it looks like higher than what we had before. So here it is requests around 250s, limits around 500, which pretty much matches the recommendation from VPA. Here let's look from the manifests as well. So yeah, here we have targets of that, which matches exactly in the new pod that we got. So that's what VPA has done to the spec. So that is within our max allowed range and from our min allowed, in between those two values that you have set there in your resource policy, and service is happily running there. And if in some point in time it will get rid of that and gives us a new pod, as I'm not currently running a stress test on that. So talking about guardrails, when using Vertical Pod Autoscaler, you do not want to not have max allowed. You want to set cap, even if VPA would have suggested more. Otherwise, any bad configuration on an app side of things, you can plot deployment with all of the available resources. So that would be handy from max allowed, from the point of max allowed. And from a caveats point of view, using Vertical Pod Autoscaler can be powerful, but it comes with caveats as every other things. So you need to consider pod eviction and restarts. So VPA adjusts resources request by evicting and restarting pods, unlike the horizontal pod autoscaler, which dynamically adjusts the number of replicas without disrupting the running pod. In this case, it will kill it. So you need to configure your pod disruption budget to mitigate that caveat. And you also need to look into resource utilization history so that you can come up and adjust your numbers on the max allowed, min allowed, so that your request and limits is more realistic. You should be able to handle the brusty and dynamic workload. VPA works best with the application with a steady resource usage pattern. For brusty workload, it's often better to use HPA, but then again, you need to make that fine line decisions. Incompatibility with HPA, so you do not want to use both together. If you have a large cluster, then it may have an eviction overhead there. And to summarize, pod eviction can cause disruptions. Of course, if you know what you're doing, you are going to not have the loss of users data, but those are the things you need to keep eye on. Incompatibility with HPAs, and then initial guesswork can lead into incorrect resource allocation as well. So monitor your resources and set the value based on your monitoring, and then allocate mins and maxes based on the data that you have. Would be the best approach. So VPA works best when deployed for stateless applications with predictable usage pattern and combined with tools like VPA for scaling the replicas, or used in conjunction with manual resource limit settings. Again, there are fine lines there. So yeah, that's pretty much about VPA. If you have any question, drop it in the comment section below and we'll try to get back to you. And hopefully you enjoyed that. We will see you soon in another video. Thank you.